Hi everyone, Krishna this side. So this is the part 2 of recursion where I'll be covering basic problems about recursion. Once we are done with the basic problems, we'll shift to the intermediate problems from the lead code. Okay. So yes, we will start looking into this few of the problems. The first one is like we will try to get first n natural numbers sum. With the help of simple for loop running from 0 till n, we can easily get the sum by adding each values, whatever the current index we are at. But yes, with the help of recursion, we'll try to see how we can get it. Okay. So to get first n natural number sum with the help of recursion, what we can do is we'll create another function. Okay. I'll name it as get sum. Okay. So in this get sum, I'll pass this n value. Okay. I already prepared this n. With the help of this n only, we will be playing around. So let me create this get sum function outside here. Public int get sum. Inside here we will pass the n value. Okay, now I already explained you yesterday that in the yesterday's video with this recursion we actually have to think about the base condition. Okay, what should be the base condition in our case, so that whatever the recursion keep on it is calling in the function itself, we have to stop somewhere, because if we do not stop somewhere, it will go on calling itself till the end, and it will go infinitely, and we will hit stack overflow. Okay, to avoid this we have to define a base condition. Every time whenever we are trying to deal with the recursion, we will uh, okay, okay, just ignore this. So every time whenever we are dealing with the recursion, we will we'll have to define a base condition. Okay, so in this case basically we are actually looking to get sum for five numbers. N is basically 5. So currently we are having 5 with us. Okay, and we need to get sum from 1 till 5. Okay, so what is the base condition that we can set? Okay, so that is something what we have to figure out. Okay, and once we figure out the base condition, it should actually match with how we are calling this recursive function. Okay, so this recursion function, whenever we are calling, it should be like it should basically deal with the base condition. Okay, that is the idea that we have to follow right over here. So what I'll do is let us look into this particular screen first. So we have this get function currently. This get sum is having value 5. From 5, I basically want to get 4. Okay, what we can do is we will currently it is having 5, so we can go to 4. I mean downside of this 5. Okay, so 4 is something what we need to get whenever we are trying to get sum. Now from 4 we can go till 3. From 3 we can go to 2. Okay, get sum of 2. From 2 we can call again 1. From 1 we can go to 0 as well, but first n natural numbers we can get it from 1. Okay, so from the moment we are calling this get sum 1, here what we can do is basically we can return 1. Okay, what I'm trying to say is like, if this n value is basically 1, whenever we reach that condition we return simply 1 from here. Okay, so the moment we do this, what happens is basically this particular function returns 1 to upside previous function. Okay, from where it has been called. Okay, so now we have to think something like we got 1. So now I need to the moment I got 1, I have to add it with 2. Okay, from this get function 2, we have to get value of 2 somehow. So how we can get it? So currently n is basically 2 at this particular location. Okay, whatever the functions that we are at this location, n value is basically 2. Okay, at this particular location n value is 2, so we can utilize it. So what we can do is n plus whatever the get sum that we got from the downside. Okay, that is something what we keep on adding. Okay, that is the next logic that we can build here. What we can do is basically we will build something like int sum. We'll give get this name, and in this one what we can do is this n value whatever we are having at each time when in the recursion call, that is something what we get, and n minus 1 is something what the function call we will do, and at the end we simply return this sum. Okay, so now how things works here. Okay, see, we are calling recursively. Currently we are having n value as 5. we go inside here, line number 20 will start executing. We check that n basically is not equals to 1. So we do not enter into there and we are not returning simply. So we go on to this line number 22. We call this sum. We see that n value is basically 5. 5 plus get sum is something what we have. So get sum of here what we are passing n minus 1. N minus 1 is basically 4. 4 is something what we got here. So again get some function will be start executing. Okay. So now until and unless we get this value of this get sum, we will not go to the next line. That is pretty much clear for us. Okay. That is something what I already explained also. That's how things works whenever we write the code in functions and all, right? So line by line the code will start executing. Now we have to get sum of 4. Okay. So how things work here is if we look here, it is like this get sum. Here we have line sum which is basically holding n, that is 5. 5 plus get sum function. Get sum is get sum of 4. Now again it go and check for this get sum. Get sum, now value of get sum is basically 4. So in this get sum, again there is a sum. So sum is basically how it is 4 plus get sum of 3, correct? Now again this get sum goes there. Again it is having this line sum equals to 3 plus get sum of 2, correct? N minus 1 is something what we are passing each time, correct? That's how our logic is working, right? Now it comes here and it is having 2 as a value. 2 plus get sum of 1. The moment we get n as equals to 1, what we are doing, we are just returning. The moment we return from any particular function, we will not execute further lines, right? So we are not recursively calling this function again in the future. Yes, we are stopping at when n value is basically 1. So we are simply returning from here, and the moment we return it, this particular get sum function is basically returning 1 as a value. Okay, so how things works now? So 1 is something what we got. Okay, 2 plus 1 is what we got. In the sum value, it is basically now 3. 3 is what we have. Okay, 3, once we got the 3, the next line will execute in the function which is having n as 2, correct? So get sum of this particular get sum is there, right? So this function basically is having 3 and this sum is basically we are returning. So once it is returning, where it been called, here it is been called, right? So correct. So at sorry, at this location it has been called. Okay, get sum of 2. So 3 plus whatever the value that we got, it was 3, right? So 6 is what the sum we have now. Again this sum is something what we are returning back. Okay, in the previous call where it has been called, it goes there and it fills out this value. So 6 is something what the value net new value that we got. Okay, in this particular get sum of 4. Now 4 plus 6 is something what we get 10. Again we are returning this sum as from this particular function. Okay, because that's how the code is basically working, right? So it looks into this particular line number, sum is something what we are returning. So it is something what get backs to the previous function call where it has been called. So again it goes this whatever the sum value that we got, 10 is something what get returned right over here at this location. The new value is 5 plus 4, it is basically equals to 15. 15 is something what we get the moment we are done from the main function call. That is how we started from there, right? So get sum of 5 is something what from where we actually started. The moment it is done, wherever this get sum function has been called, right over here line number 5, whatever the answer that we got, 15 is the answer that we got, right, at the end. So sum is basically holding 15 as an answer. Okay, now we can try to print out this sum value. So let us print this sum and we should get 15 as an answer in the output. Okay, let us run this code. So if we see here, answer is basically equals to 15. We can try out different possibilities, like for 4 it should be 10, correct? So let us run this code. So recursively, it will go and keep on calling this particular same function itself and the current value whatever we have. So it is like 5 plus sum till 4. Then the moment we reach to 4, 4 plus sum till 3. Then it is like 3 plus sum till 2. Then it is like 2 plus sum till 1. The moment we are getting n value as 1, we are returning simply from there. So that this recursive call is something we are stopping right over there when n value is basically equals to 1. Okay, we can handle different conditions. Okay, so if n is what is n is equals to 0, right? So that for that one, if n is basically less than if it is like negative values, for those also different conditions we can handle so that we cannot go into this recursive call, okay, in the future. So yes, different base conditions that we can set so that we won't be going inside this recursive calls. What if the negative value is something what they have given and they asked to get n natural number sum? So it is not a natural number, right? Negative value. So we have to make sure that these different base conditions are also getting handled. So what if like if n is actually less than uh, let us suppose 0, it is basically negative value, so we can simply return whatever the value that we want. Negative minus 1 is something what we are returning. So what if, let us suppose n is basically minus 4, so minus 1 is something what we need to return, so that we are not going here inside this recursive calls and we are not keep on calling these values, okay, because the base condition should be like this one or this one, okay. So these are the base conditions that we need to define whenever we are calling the recursive functions, okay. This is for the get sum. Now let us look for the next particular function that we are trying to get. So factorial of a number. So how the factorial of number works? If n is basically equals to 5, factorial of 5 is basically it is like 5 into 4 into sorry, it is into 3 into 2 into 2 into 1. Okay, 2 into 1. That's how factorial of 5 basically works, right? Factorial of 5 equals to, okay. This is how factorial of 5 works. If it is 6, we will start from 6 into 5 into 6 into 5 into 4 into 3 into 1. Okay, that's how a factorial of a number works, correct. Now we are actually known that 6 factorial is like 6 into factorial of 5, correct. 5 factorial is like basically 5 into 4 factorial. 3 factorial is basically 3 into 2's factorial, and 2 factorial is basically 2 into 1's factorial. So okay, the idea is pretty much simple again. So in fact is something what I'll name here, and get fact I'll just name shorter, okay. So in this get fact, let us define this get fact function as well. Public static get fact. Okay, here we will be having int n. Okay, now we again here also what we can do is let me define here public static int. Okay, so get factorial of that particular number is something what we are returning. Okay, so it should be long if value is going beyond some huge value if we have. Okay, let me set it as a long. So here we got int, and what we can do is now inside from this particular one we will again do the same thing. Base condition is something what we have to define. So n is basically 5, so 5 factorial is basically 4 into 5 into 4's factorial, right? And the end where we are ending it, when n is basically equals to 1, we are stopping there. So again we can set the same condition. If n is basically equals to 1, we will simply return 1, because from there we are returning 1. But 2's, for 2's factorial, what we are doing, 2 into factorial of 1, correct. That's how we are doing. So for 3's factorial, 3 into factorial of 2, factorial of 2, that is how we are doing. So yes, we are actually got to know that we can get factorial. So what I can do is fact equals to 3 into, that is like n into, so whatever the n value we have, n minus 1. Okay, pretty much straightforward. Same logic that we applied for this get sum. That is how we are doing it, and the fact whatever the factorial that we are getting, we are simply returning from here. Okay, the factorial of n minus 1 is something what we are returning, so we are getting it fact equals to n into get fact. Okay, it is not fact, so get fact of n minus 1. Okay, we are keep on doing the same operation. So again the call stack, how the things looks into this particular call stack is, if we look here in this particular image, so if they asked n equals to, let us suppose 6, 6 factorial equals to, it is like 6 into 5 into 4 into 3 into 2 into 1, correct. So what we can do is basically the base condition is when we reach to 1, we are simply returning 1, because 1 factorial is basically 1, correct. So that is the base condition that we have. So now what we can do is right over here inside this particular one, we will be checking that if n is equals to 1, we are simply returning 1. Otherwise what we are doing, whatever the number that we have, 6 factorial, let us suppose if n is basically 6, 6 into factorial of 5. Okay, 6 into factorial of 5. So here 6 into factorial of 5 is something what we are doing, correct. That is what we are trying to do. Now 5 factorial is basically 5 into factorial of 4. Okay, that's how the call stack basically working, right? So again it factorial of 4 is like it goes into this particular function. If n is basically equals to 1, we will go into that one, but it is not, right? So it goes here and checks n is equals to n into factorial of this n is like n into get factorial of n minus 1. So it is basically again like 4 currently, because at that particular get function, get factorial function, their n value is basically 4, correct. Recursively, that's how the call is happening, right? So 4 factorial is 4 into factorial of 3. Again 4 factorial of 3, it is like 3 into factorial of 2. and for 2 it is 2 into factorial of 1. Okay, now for the moment we get 1, uh, what we do, we are simply whenever the factorial get factorial function, we are at get factorial function n is equals to 1, we are simply returning it, so that we will keep on not going into infinite of this particular loop, calling this loop infinitely. Okay, so the factorial of 1 is basically 1. That is something what get replaced right over here. Now we got that 2 into 1 is the answer that we got. This value is something what we are returning it at the end. Okay, we are storing it into the fact, and the fact is something what we are returning it. Now wherever this factorial function is been called, okay, here it is been called, right? From there only we derived right over here. So whatever the value that we got, 2 is something what the value got, so it will replace it right over here with 2. Okay, that's how things work, right? The moment the function's work is done, whenever we are returning from the function, we will get whatever the values. If it is returning whatever the functions, if it is done, we will start executing the next line from previous function. So in the previous function, 3 into 6 is basically 6. 6 is something what get replaced right over here in the previous function, because that is something what we are returning at the end. Okay, so now 6 is something what return backwards. Here it is like 6 into 4 is like 24 is something what get written right over here at this place. Now I am not good at this math, like it is I think 120 is something what we get. Okay, so 120 is something what we get right over here at this particular location, factorial of 5. And again if we do 12 into 6 is like uh, 6 720 is something what we get. Okay, 720 is something what we get, that is something what we return back previous to this particular function where it has been called. So get factorial is something what called here, so 720 is something what replaced right over here. Okay, so it is kind of easy. Now what we can do is n is something what we pass here. Now I'll print to the fact answer. Let us run this one. So if value is basically 6, correct, so it should be 720 is the answer that we should get. Okay, let us run this one. 720 is something what we got. Okay, so yes, if it is 5, it should return 120. Let us run this code. It should 120. If it is 4, yes, we can try it out different possibilities. Okay, so that's how we can write the logic for the factorial as well. Now let us look for the next particular function. We have to check if string is palindrome or not. So what is the palindrome of a string, right? So since I'm considering for the beginner level guys, if you guys not aware, let me tell you. Palindrome of string is when a string, let us suppose A, B, C, ABD, ABC, and then BA is something this string is we have. So the starting index and ending index should be keep on matching it. Okay, so here if we read it from the starting and if we try to read it from the end, both the strings should be equal. Okay, so if we read this particular string from the starting, it is like A B C B A, but if we read again from the ending as well, B A B C B A, the same thing is something what we are getting it, right? So it is a palindromic string. What if this is the string that we are ABC? So if we read it from the start, it is like ABC, but if we read it from the back, it is like CBA. Both the strings are not equal, so it is not a palindromic string. Okay, so this is something what we'll try to figure out. Okay, so what we can do, let us create a boolean. So each palindrome. Okay, so we'll see if whatever the palindrome, whatever string that we are doing, if it is a palindromic string or not. So we will create a function check palindrome, palindrome. Okay, in this check palindrome, I'll pass from the 0th index we are checking. Okay, and let us create a string right over here. Let us suppose we have this string x, or in this x string I'll set up values a b c b a. Okay, so let us get the length of the string. So let us get int len equals to x dot length. Okay, so we are just getting the length of the string, so that uh, since we are checking this string, if both the strings are equal or not, we can easily compare the last and first character. If they are equal, we will go to the second last and second character. If both are equal, again we keep on shrinking it until and unless both the characters are equal. At the middle of the string when we reach, till then we have to keep on checking. And this left pointer and the right pointers are something what we will be using here. So currently we are starting from the 0th index, and we will right pointer is basically pointing to the end of the string. So len, sorry, it shouldn't be like this. Okay, sorry, I was just discussing and I was writing the code. So len minus 1. Okay, we are going till the end of the string, and x is the string that we have. So we are checking if the string is palindrome or not. So let me create the function. So it is like public boolean. Okay, it should be static boolean is check palindrome, and we are passing here left pointer. We have here, we have right pointer, and string x is something what we have. Okay, so yes, we are keep on incrementing the left pointer's value, right pointer's value is something what we are keep on decrementing, and we have to make sure that uh, the moment this left pointer actually greater than the right pointer, we should break from the string. That is the first condition. Okay, if that is the condition we are meeting, we are simply done with this one. Okay, the string is basically palindromic string. Okay, so the base condition what we can set is if left is actually greater than right. Okay, or left is actually equals to right. Okay, so what if the string is actually having odd length? Okay, a this is having odd length of 3. So a character, currently left pointer is pointing to 0th location, b right pointer is pointing to this third location. Okay, so both characters are equal, left pointer got incremented, right pointer got decremented. So both pointers are pointing to the same element. The moment left and right pointers are pointing to the same index, actually the string is palindromic string. Okay, because it is basically the middle element is actually common element in both of the strings. So we can read it from the right to left, left to right. It will sound the same. Okay. So yes, the next is like if the string is like having even length. Okay, this is having even length. So left is basically at 0th location, right is basically at this location. So left pointer pointing to here, both the strings as in both the characters are equal. Right pointer points here. Now both BB are also equal. So right pointer get pointing to right or at this location. Left is basically pointing to this location. Okay, now here left is actually greater than the right. Yes, both the strings are equal. So in that particular case, what we can do is we can simply return true. Okay, so that is the first case. And what next we can do is we will try to get boolean is palindrome. Okay, inside here what we can do is basically we can again call this check palindrome. Okay, in this check palindrome what we do is basically we increment the left pointer by 1, whatever the left value that we have, right pointer we will decrement it, and x is something what we have. So before this checking is palindrome, okay, we have to put another condition. Okay, what is that condition? If whatever the character that we are at, whatever the character x dot char at left, this should be equals to x dot char at right. Okay, then only both the strings are both the character, the moment we say that both the characters are equal, we can decrement it. Okay, we can go further. If this is not the case, we can return false from here. Okay, we can simply return false from here. Okay, that is the another condition that we are having. So whatever the value that we are getting at the end, we can simply return that. Okay, so it is not necessary that we have to store these values in some variable and that we have to return. We can simply return right from here as well. Okay, we will be returning it. Okay, I'll explain you this particular code again. Just wanted to write logic. So see how things are happening. Okay, let us look into this particular screen. Let us say that we will be having this a b a, and second is a b a, sorry, a b b, sorry, it is like a b b a, that is the second string, and third thing is a b c. Okay, these different strings that we have. So what we are doing is like we are currently pointing our left pointer right over here, right pointer is basically pointing to end of the string. That is what we have derived it from this check palindrome. This is the left pointer, this is the right pointer, basically pointing to the last character of the string, and x is the string that we have. That is something, those strings we are passing it right over here into this check palindrome function. Okay, uh, yeah, whatever the name is there, check palindrome, inside here we are basically passing these values. Now what we are doing, we have to make sure that whatever the this character that are there, 0th location character and first location character, or the last character, both should be matching. Okay, if they are not matching, when we try to read it from the other side, definitely it is not equals to what we have. Okay, so both the characters should be matching. So here the basic condition is like we have to check that if left pointer and right pointers are matching or not. Okay, if both pointers are characters are matching, we simply can, what we can do is our left pointer will start pointing to next index, right pointer will start pointing to previous index. Okay, in this particular case, in this first example, how things happens. So currently left pointer is, yeah, left is basically equals to 0, right is basically equals to 2. Okay, and zeroth character and first character both are matching. Okay, so in this one, this is the base condition that we have, and this is the again another condition we are checking here, that if character of left, character of 0 and character of 2, if both are not equal, then we are returning simply false. But in our case both are equal, so we are not entering into this condition. So we are going further, we are calling recursively same function again. So what happens? So left pointer and right pointers are currently, they are 0 comma 2 are the left and right pointers. Again we call recursively the same function. Check palindrome. Okay, check palindrome. Here the left pointer is basically 1, right pointer is basically 1, because left pointer getting incremented, right pointer getting decremented. Okay, now again we check that if left is actually equals right, in that particular case we can return true. Okay, the moment we get to know that both the characters are equal, we can simply return true. Okay, because that is like odd length string, and in odd length string the middle character should be equal to both the strings, right? So here left is actually equals to right, so this is like this string whatever we are at, the character b is the character where we are at, so we can simply return true from here. So it goes back in the previous function, wherever it has been called, here it returns true, and the moment we get true value in the previous function, it is basically return true back to the this particular one. Okay, so yes, that is how things are working. What if for the next example we have like it is like a b b a, in this one left is basically, in this particular example left is basically at zeroth location, right is basically at third location. Okay, so both a and b are equal, so yes, of course we are not entering into this line number 25, because left is actually less than this right, and both are not equal, so we are not entering into that condition. That is the base condition that we have. In this line number 27 also we are not entering, because both the characters are basically equals. So we again call the same function where we are passing left plus 1, right minus 1. Okay, we go here, left is basically 1, again calling the same function where left value is basically 1, right value is basically 2, because right is something what we are decrementing and the string is something what we have. From here again we check that we are now left pointer is pointing at this location. Okay, and right pointer is pointing at this location. So both the characters we keep on checking. So of course we are not entering into this condition, but we check that if left is not equals to right, something there, here is something what we are entering, correct? So yes, both are actually equals. Okay, because they are like b and b, both these characters are equal. So yes, if they are equals, again what we do is left pointer get incremented, right pointer get decremented. So left is now pointing to at this location, here is left something what pointing, right is pointing at this location. If that is the condition where we met, that means all the characters from the left to right are equal basically. Okay, we can see, right? So yes, we can, if we read this particular string from left to right or right to left, both strings are equal. So yes, we got to know that we are entering into this base condition, left is actually greater than this right, so we are simply returning true. So what happens in this particular one, the moment we reach at this particular location, it basically returns true to the previous function. Now here once it get true, it basically we are ending into this one. Okay, that is the end of the function. Okay, so it basically, the moment we get true, this basically returns to the previous function true. Okay, this also returns true back to the previous function. Okay, now the moment we got true into the last function from where the call stack has been called, so it basically goes to the call stack where it has been called, and here it returns true. So this each palindrome is basically having true value for that one. Okay, so there was another example here like ABC. The first step itself get failed, because left is basically at zeroth location, right is basically at first location. Okay, and in this particular one we check that first line we are not entering, because our left is actually less than right and both are not equal. In the next condition it checks character at left from this string, So it is basically A, and sorry, it is basically A, and character at right location, it is basically 2. Okay, character at right location is basically C. Both the characters are not equal. Okay, so since both the characters are not equal, we are simply returning false from there. Okay, we are simply returning false. So yes, you can try it out different examples and you can understand it. Okay, so that's how we can solve this particular one, and we can get the answers. Okay, uh, so yes, we can get the answers into this particular is palindrome, and we can return it. So recursively, this is how we can keep on calling them and get the answers. Okay, let us try to get the answer for this particular. It should return true. Let me run this code. So if we notice here in the answer, it is returning true, correct? So what if the string is like this one? It should also return true, right? It is even length string, and here we will be mating in this particular condition. Okay, left is actually greater than right, so it is also true. But what if I just add here another r as a character? So if we try to read it from left to right or right to left, both the strings are not equal. So when we run this particular example, uh, it should return false. So that is what we are getting it. Okay, so yes, next function is like we will try to get the power of a number. A is power of b. Okay, so particular power of a number is like let's suppose 2's power of 4. Okay, this is something what we have. How it is been written? So it is like 2 into 2 into 2 into 2. 4 times 2 is something what we are returning, correct? So it is pretty much straightforward. Again, like how we are getting the factorial of a number, we are just whatever the number that we have, we are getting it, and whatever the value of this one, we are keep on decrementing. The moment this value gets reduced to 0, we will return basically 1. Okay, because 2 power of 0 is basically 1. Okay, the end is something like 1. The moment we reach that, we are returning simply 1. So let us write this code as well. So it is like 2's power of 4 is basically 2 into 2's power of 3. 2's power of 3 is basically 2 into 2's power of 2. That's how things are deriving right over here in this particular. Okay, so how to write this code again? We will again get int n is basically already defined the number. Let us get power of value. So it is, let us define 4. N is basically here, let me set it to 2. So now we got n and this power of value. So we can create function which gives us the value int uh, power. Okay, I'll just name it as power, get power, and here I'll pass n as this n is basically pointing to 2's power of this value. Okay, so let me name it as a val, and let me name it as a power, and value is something what we will pass. So it is like 2's power of this value, whatever the value that we have. Let me define this get power function again. We'll create here public int get power. Okay, it should be static. Okay, in this particular get power, I'll be having int n, int val. Okay, so we check that if val is basically equals 0, we'll simply return 1 because that was the base condition, and power of 2's power of 4 is basically 2 into 2's power of 3. So yes, we can keep on calling this function and reduce this value, whatever the value that we have, and from here we can simply return like n into get power of n with value reducing it. Okay, so that's how we can keep on calling this one, same like how we are doing with the factorial or whatever the other properties that we tried out. So how this works, let us quickly look into this particular screen. So value of n is basically 2, and power value is basically 4. Like 2's power of 4 is something what we are looking at, so it is represented as 2 into 2's power of 3. This basically represented as 2 into 2 into 2's power of 2. Okay, this basically represented as 2 into 2's power of 1. This basically represented as 2's power of 1 into 2's power of 0. Okay, that's how things works, right? So yes, these are like recursive functions that we keep on calling, and the moment we get the answer, we put it into the previous value. The moment we get this answer, we keep on putting into the previous values. Okay, so yes, how the things works, 2 into our current function is like until unless this value is basically equals to 0, we are keep on calling this particular power of function. So 2 into power of 2 comma value of 3. This will call again like 2 into 2 comma the value is basically 2. This will call 2 into 2 comma 1. This will call 2 into 2 comma 0. Okay, it is updating very slowly. I think machine is getting hit up a lot. So this value, the moment we reach that these values are n is actually equals to 2 and value is basically equals to 0, we are returning it so that we can stop this recursion calls further. So it is returning 1. So this function, what it returns, basically it returns 1. So at this location we will be having 1 as an answer. Okay, now 2 into 1 is something what we got, and that is something what we are returning it from that particular function. So this particular call, whatever the call stack we are at, this particular function call is basically derived from this location, right? So it goes back at this location and it replaces with 2. Okay, now this particular is been called from here, so it multiplies 2 into 2 is basically 4, is something what get replaced at this location. And same goes with the previous functions and keep on getting updated. Okay, it is really lagging a lot, so I have to stop this screen whatever I'm running at, because it will be then problematic. I cannot explain you. Okay, yes, that is as pretty much straightforward as it is, and we'll try to get the answer like what is the power of this n into l. So the answer whatever we are getting, that is something what, let us try to print it. So 2's power of 4 is basically equals to 16. That is something what it should return in the answer. So if we look here, it is returning 16. So 2's power of 5, let us update this value as 5. So it should be 32. Let us run this code. So it is basically returning 32. Yeah, that's how things works. Okay. Now Fibonacci of a number is something what we will try to solve this one. Okay. So Fibonacci of number, let us suppose n is basically 5. If they asked to get Fibonacci of first 5 numbers. Okay, that is something what they are asking. So how this works is like see, Fibonacci series like basically starts from 0, then it is having at first index it is having value as 1. The next value is basically whatever the previous two values that we have, the sum of those two values is something what we have to write. Okay, so here it is going to be 1. Again, previous two values sum is basically we have to write at this location, it is basically 2. Now 2 plus 1 is basically we have to write for the next one. Okay, now again 2 plus 3 is something what we have to write for the next one, it is going to be 5. And yes, 5 is something where we are trying to get the sum. Okay, till 5 we are trying to get the sum. Or first n numbers, first n basically n equals to 5, till that sum is something what they can ask. Okay, so yes, the Fibonacci series basically starts from 0 and 1, then keep on previous two index values sum is what we have to get it. Okay, let us write the code as well. I just disconnected that machine because the laptop is getting heated very frequently, and I cannot explain you guys this particular solution. So we will not look into this regression tree, but we will try to solve this one. Okay, get fifth series. Here I'll pass the n. Okay, and what we can do is let us define this get fib. Let me create this function public static int get fib. Here we have n as the value. Okay, so the base condition is if n is actually equals to 0, we will return 0. If n is actually equals to 1, we will simply return 1. Okay, because at 0th location the sum till that location is 0, at first location sum till that location is 1. Now if n is actually equals to 2, the sum is like previous two values sum is something what we can get it. Okay, so let us say that if n is basically equals to 2, so what we can do is Fibonacci of n minus 1 and Fibonacci of n minus 2 is something what the sum we can get it. And sum equals to fib get fib of n minus 1 plus get fib of n minus 2 is the value that we have to get it. So if they have said that get sum till 2, so Fibonacci of n minus 1 is basically 1. 1 plus Fibonacci of n minus 2 is basically 0. So if this particular function will get sum as 1, this will get a value as 0. So 0 plus 1 is 1. The 1 is the answer that we can get it. So simply we can return this value. Okay, return this sum that we are getting it. Okay, so this is the series how we can get it. Like the value for Fibonacci when n equals to 2 is like it is basically this value plus this value. Okay, so we are having both the base conditions currently with us. What if n is basically equals to 3? Okay, so in the 3 we will try to get Fibonacci of value for 2. For 2 it is basically 1, and Fibonacci of value 1. For 1 it is basically 1. 1 plus 1 is 3. Basically 3 is what the answer that we can get it. Fibonacci of 4 again is like Fibonacci of 3 plus Fibonacci of 2. Okay, Fibonacci of 3 is again like how we derived it. Again it goes here and it try to get Fibonacci of 2 plus Fibonacci of 1. Whatever the value that we are getting, that is something what get written into the Fibonacci of 3, and Fibonacci of 2 is something what we get it written again back here, and whatever the sum that we get, that is something what we return. That's how things works in this Fibonacci. Okay, so if n is basically something what we pass and try to get the answer, we can run this code. So yes, so whatever the value of n, if it is 2, the value is basically 1. If it is 3, the value should be 2, correct? So that's how we are getting it right. Fibonacci of 3. Fibonacci of 4 is basically it is equals to 5. So 5 is the answer that we should get. So if I put 4, okay. So Fibonacci of 3 plus Fibonacci, okay, 3 4 it is like 3, okay. Fibonacci of 5 is basically 5, okay. So let us get that answer as well. Okay, that's how we can derive it. I couldn't explain you guys with the help of recursion tree, but yes, you have to think inside your mind, like you just try to get the recursion tree, try to do by your own hand, and try to solve this particular problem with your efforts, and keep practicing it. The more you practice, the more the grip you will get it with the recursion. So yes, I'll now from next video onwards, I'll cover the lead code problems, all the lead code problems that I mentioned in the previous videos. So that is having backtracking concept as well, and those are medium level problems. So yes, before going there, if you do not have any practice about these type of problems, so please make sure to get hands-on experience on this type of problems so that we can get easy there. Okay. So yes, thank you for watching this video. Bye bye.